You ever stop and think about what's actually happening when you scroll through your social media? You know that split second between your friend posting a photo and it magically appearing on your phone? Well, today, we're going to pull back the curtain on that. We're diving into the massive, super complex architecture that powers every single news feed out there. We'll break down how these systems manage to get personalized content to millions, literally millions of users, all in the blink of an eye.
I mean, we all do it, right? That endless scroll through updates, photos, videos. It feels so simple, so seamless. But, behind that smooth interface is this just monumental engineering challenge. How in the world do you get the right content to the right people at exactly the right time, all at a global scale? Yeah, that's the puzzle we're going to solve today.
So picture this. You're in a job interview. This is the classic system design question. It's big, it's open-ended, and honestly, it's designed to test not just what you know, but how you think, how you approach building something massive from the ground up. So let's do it. Let's walk through exactly how to ace this thing step by step.
Okay, so here's our roadmap for today. First, we'll define the challenge, figure out what we're actually building. Then we'll lay out the big picture foundation. After that, we're going to dive deep into the two core mechanics, the publishing flow, that's creating posts, and the retrieval flow, which is viewing them. And finally, we'll wrap it all up by looking at the tough choices, the trade-offs, and how we can make our design even stronger.
All right, first things first. Before we even think about drawing a single box or writing a line of code, we have to ask questions. We need to clarify the requirements. I mean, think about it. Just like in a real project, or especially in an interview, you just can't build a good solution if you don't really truly understand the problem you're trying to solve.
Okay, so we've got our requirements locked in. We're talking users can publish posts, they can see their friends' posts, and the feed is going to be sorted in reverse chronological order. Simple enough. But here are the big ones. We need to support 10 million daily active users. A user can have up to 5,000 friends, and the feed can have text, images, and videos. Now, these aren't just bullet points. These numbers, especially that 10 million DAU, are going to dictate every single architectural decision we make from this point on.
Okay, with those requirements locked in, it's time to zoom out. Let's sketch out that 30,000-foot view. We need a high-level blueprint that shows the main pieces of the puzzle and how they're all going to talk to each other. We have to do this before we get lost down in the weeds.
At its core, you can really split this whole system into two fundamental parts. First, you've got the write path. We call it feed publishing. That's everything that happens when you create a post. And then you've got the read path, or newsfeed building. And that's what happens when you open the app to start scrolling. We've got to make both of them super efficient, but believe me, they present completely different challenges.
And here it is. This is our high-level blueprint. So on the left, you've got the publishing flow. A user's post comes in, it goes through some web servers to a post service to get saved, but it also goes to this thing called a fan-out service. Now, just think of fan-out as the process of distributing that one post to everyone who needs to see it. Then on the right, you have the retrieval flow. It looks a little simpler, right? A user just asks for their feed, and a news feed service grabs it from a cache. These two halves, this is the foundation for everything we're about to build.
All right, let's do our first deep dive. We're starting with the publishing flow. We are going to trace the entire journey of a single post, right from the moment you smash that send button all the way until it pops up on your friends' feeds.
Okay, let's follow the data. So your request to post something hits a load balancer, then a web server. The post service is pretty straightforward. It just saves the content to a database. But at the exact same time, that fan-out service we talked about kicks into gear. And this is the crucial part. Its job is to figure out who needs to see this post and then make sure it gets delivered to them.
So let's zoom in on that fan-out service, because this is where the real magic, and frankly, the complexity, really happens. When you post something, the service grabs your entire friend list, and then it has to go and update the feed for every single one of those friends. And this, right here, leads us to a critical design decision, one that has absolutely massive performance implications. And here it is. This is the classic push versus pull dilemma. So, option 1. Do we push the post into every friend's feed the second it's written? That's great because reading the feed becomes super fast, but if someone has 5,000 friends, that's a ton of work to do all at once. Or, option 2, do we wait for a user to log in and then pull all their friends' recent posts to build their feed right then and there? That's way better for users who don't log in often, but it makes loading the feed feel a lot slower.
So what do we do? Well, there's no single right answer. The really elegant solution is to use a hybrid approach.
For most of us, with a normal number of friends, the system will just push our posts out immediately. But for a celebrity, someone with millions of followers, it switches to a pull model. This is so important because it prevents a single viral post from creating what's called a thundering herd problem and just totally overwhelming the system. It really is the best of both worlds.
Okay, so we've successfully published a post. It's out there. Now let's switch gears completely and look at the other side of the coin. What actually happens when you open the app ready to see what's new?
The retrieval flow is all about one thing, and one thing only: speed. When you open that app, you expect to see your feed instantly, right? The system has to assemble everything and deliver it to you in a flash. And you can see here, the news feed service is the heart of it all. Its entire job is to be the orchestra conductor, pulling all the little bits and pieces of data from different caches to build your feed on the fly.
Now here's a key insight. Your feed isn't stored somewhere as one big, fully formed block of data. That would be crazy inefficient. Instead, the system just keeps a really simple, ordered list of post IDs just for you. Then when you open the app, it grabs that list and hydrates it. That's a great term. It means it quickly goes and fetches all the actual details, the post text, the user's name, their profile picture, from other places to assemble the final feed that you actually see on your screen.
Caching is really the unsung hero of this entire design. Seriously, hitting a database is slow. It's like having to go to the library. Hitting a cache, which is in memory, is lightning fast. It's like having the information right in front of you. To make this retrieval flow feel instant, we absolutely need an aggressive, intelligent caching strategy that keeps the most important data ready to go at a moment's notice.
And we don't just use one giant cache for everything. No way. We create multiple, specialized layers. So there's a cache just for that list of post IDs for each user. There's another one for the actual content of the posts. One for the social graph, who's friends with whom. Caches for actions, for counters. And this separation is absolutely critical. It allows different parts of the system to grow and scale independently, and it makes sure we only fetch the exact data we need, which makes the whole thing incredibly fast.
A great answer in a system design interview. It doesn't just stop with the diagram. The best answers go one step further. They critically evaluate the design you just made, identify its weak points, and start thinking about how to make it better down the road. That's what we're going to do now.
So, if we have to critique our own design, what's the single biggest bottleneck? Well, it's that hotkey problem we touched on. That's when one single piece of data, like that celebrity's post, gets accessed way more than anything else. And even with our clever hybrid push/pull model, that one post still creates this enormous pressure point on the fanout service that has to be managed really carefully.
Now, here's a question that forces us to think beyond the happy path and really consider reliability. What happens when a server just dies, or a network cable gets cut? A truly robust system has to have redundancy built in at every single layer. We need multiple web servers, we need copies of our databases in different data centers, and we need automatic logic to switch over to the backup if something fails. You have to plan for failure.
And here it is, the final challenge. This is the perfect way to end an interview. Scaling from 10 million to 100 million users. That's a 10x jump, and it is not just about buying more servers. It's about fundamentally reevaluating every single piece of this design, from the databases to the caching strategy to how you distribute data globally. And it leaves us with this really important thought. Great systems are never truly finished. They are always evolving.